Everybody, this is dexxcore 3, dexxcore, wait what? I know that sounds confusing, but this all is the dexxcore library, but this is the main dexxcore header and CPP, which contains all the other functions, which is why, as you could notice, our string and memory functions are no longer here. Basically, this dexxcore functions, or binary, is what contains all the functions and adds a few unique functionalities. For instance, we have some global variables, and the resource path is where your project's resource folder is located, where all your sprites and stuff will be, and then you have the exe path. And that just pretty much, because your exe path can change. For instance, right now it's located in my new project build, but if you were to copy this and run it somewhere else, it would actually have the exe path where you place it. Then there's the test build, and what this is it's a boolean that says true if we're running it in our project, and then it says false if we've given it to a friend or something and it's running on its own. Actually, we can use toString that will take a boolean and output true or false. But I don't even know why I'm displaying this, because it already displays on the bottom here. But just to give I'll show the test build boolean in action later. Like, for instance, right now it says true because we are testing this in our project build. And then there is the is running, and basically it's a boolean that tells you if the project is running or not. But since we really just have dexxcore added and we initted it, and we're not really in the main project loop, is running, frame ticks, and frame per second at the moment currently don't do anything. But the argument count and argument are pretty much right here. Argument count and argument, I don't know what V stands for, vector, but anyways, it's a list of given arguments, and you can see that down here where it says argument 1, and no matter how you build your product or anything, the first argument will always be filled with the exe address, which is how the exe path gets its location so accurately, is it just uses the default value that's in here, which will always give you the exact directory location of where your executable is. But other than these basic variables, we also have the assert, and this is pretty cool because you can give it a test, and if it comes up true, it'll end the program, and if it comes up false, it will continue like nothing happened. But basically, you put in a message. It can be a string variable or here, and we'll just call it testing assert. And now when we run the program, the assert will be called and create a red error, and it will say testing assert, which is the message we put in, and then it gives you the details of the file was in main CPP, which we are in, the line was 9, which it was, and the function was main. And what's cool is I can add like another function, apple, and call it in here and give it a different message like apple function fail test, and of course, you can't call functions that are declared after the function that's calling it unless you declare your function. So we have to declare it. And what that's saying is we've declared main here, and main doesn't know Apple exists because Apple was created after the main function. So we pretty much tell it that Apple exists up here so it can use it down there. But when we run this, oh, it'd probably help if I called the function. As you can see, Apple function failed test, which is what we put in there, and now it says file main CP line 18, which it is, and then it says function is Apple. So basically, the assert is amazing because one, it changes the text red, which gives you a visual like color to easily find it, and two, it gives you the exact file, line, and function that this was called. So whenever you're creating like different function libraries or whatever, and something like, for instance, when the dexxcore runs, it relies on OpenGL to work, and if it tries to init OpenGL or start it and it fails, there's no reason on continuing on the program because the program is more than likely a graphics program. So what you would do is you would call an assert and give it a detailed message of why it failed, like maybe a file doesn't exist or something. I mean, there are many reasons why it could fail. But the next one is the logging function, and this basically replaces the stdc out. But what's cool about this log information, or this log app, is that it has different log defines that you can put in it, and you can even change text color. For instance, log yellow slash then line log default. And now what log default does is it'll return, like log yellow will turn the text to yellow, and if you didn't have log default, it would literally turn everything yellow, but we turn it back to default. And in my properties here on color and screen text, I've set the blue color as the default, so that means it'll go back to blue. Which is why in all the other videos, when I was using my terminal, it just kept being white and crazy. It wouldn't stay blue, because for this to maintain its color and everything, it depended on the dexxcore library or binary. But now if we were to run this, oh, Apple doesn't exist anymore. If we were to run this, now it says hello weirdo in yellow. And actually, I was wanting to use this assert to show you guys the, well, the test build value in action, and here it is. It says test build is true because we're building it here. And I also wanted to show you the arguments here. So what we would do is we would go into our build folder and we would open the CMD here, and then we would open this app directly by calling its name. And then you can pretty much give a program that you open a argument, or an argument. For instance, and then when you run the program, as you can see in here, the argument count is now 2 because we ran the program and gave it a different argument. And this can be used a lot if, like, for instance, I have a program and another program opens it and I need it to open in specific states. I will just give bizarre messages, and what the program will do is it'll check its argument count, and if the argument count is greater than 0, it'll read and try to react with whatever it's sent. And as you can see, test build says false because this is not running in the project environment. And this can be used to determine if you're the one creating the program, because when it says test build and you're building it, it'll say true, but then when you've copied the program and sent it out to someone, it will be test build false because it is no longer a test build. If anything, it's a release project. For instance, if we were to come in here and build it again, it would say test build true. Now, as far as the so I understand why my color coding isn't working here, and I will definitely fix that, but I normally do not run, like normally when I have the actual program, I actually disable the terminal so it just runs as a graphics window, so I normally don't deal with that. But basically log is like, for instance, log default puts it back to its default settings on everything, and you've got log bold, which it seems to just make the color a little lighter, and then you have log underline, which means that we can, like for instance, we had a, like I like this example right here. It takes log and a double speed equals 0.6. And basically what we're doing is we're turning it yellow, we're turning the underline on so that speed is underlined, and then we're turning the underline off so that way when we print the variable speed, it is not underlined, and then we log default, so we turn everything back to normal, and then we new line, which you could new line before you default, it just happens to be the order that's done in here. But now that we've run this, it would have speed underlined and then the variable, which is pretty cool. And then of course it errors because we have our assert still. But basically you've got the underline, the yellow, or you've got the bold, the underline, and this one reverses the colors. Like for instance, I'm pretty sure that if we did that, it would be black text on yellow. Yeah. So, and then obviously if you call log default, all these settings will be back to normal. But for some reason, kind of like how we use the underline and we wanted to turn it off, there's also a no underline, so you could, or a no reverse right here, so you could turn it off. But these are all the colors you can choose from. And honestly, I just really like the log colors because I'm a visual. And it also maintains this from being blue. For instance, if I go make clear all and we run into an error that turns it all white like before, once it gets up to running the program, it goes straight back to blue, to where all the other previous videos, as soon as it ran into some kind of warning or error, it just stayed white and ugly. And then you can clear screen and then just run it again. But there's also the app end and app restart, but I haven't really made these yet, but they're supposed to be where this will end the app and then this will end the app and then start it up again, which is where the X processing library is going to come in handy to help start up the program. But so far don't really have that yet. And I think that the next video will be around data structures. So this was just a quick video to show off the small dexxcore CPP file that will include all of the other functions and a few extra global variables and 2 functions, assert and log, to help you print to the terminal in color or in style in this case, and you can pretty much load it up just like with any data you want, just like you would do. And that's one thing that's cool too, is when you use stdc out, you have to constantly put something here, then you have to do the brackets again and put a 5, and then you have to put more brackets, to where when you use log, the only thing you got to do is just log, and then you can put a string here, and then all you have to do is do that, and then you can put a number, and then do it again and put resource path, and just any variable you want, and then you come in here and make run, and there it is. And just to show you what happens when you log green and you don't default it back, it'll basically maintain everything green. Well, as soon as you run the program again, it should put it back to blue, but like if I was to run this like even before the dexxcore setup, like all the way up here, so I'm guessing this actually sets it back to the default, which is nice. But if I was to, actually these set it to default too, but either way, just make sure you clear the colors or it'll bleed all the way through until someone calls log default, which apparently I call log default a lot every time I use a color, so it's not as violently destructive as I thought it was originally. But anyways, that's the dexxcore library, and I'll see you guys when I do the data.